Hi guys, so this is the video lesson to go over GCF-LCM practice. The PowerPoint slides look just like my screen. Please make sure you have them split screened with the video lesson so you can fill them out as you go. Okay, so let's take a look at problem number 1. It says General Mills needs to make cereal boxes that are the same width and can fit on both 48-inch and 56-inch shelves with no space on either side. Question asks, what is the widest box that will work? So our key word here that we want to focus on is the word widest, right? Remember when we went through our word problem keywords, GCF was when we were looking for the greatest number or greatest size, or we were splitting into groups, or equally splitting something up. So in this problem, when they're looking for the widest box, right, they're looking for the greatest width of a cereal box that would work. So this problem is definitely going to be GCF. So we look at our two numbers. We have 48 and 56. Those are the two numbers we'll have to find the GCF for. So first, let's start with 48. I'm going to draw my T-chart and then list my factors, right? Because I'm looking for the greatest common factor. So I need to list my factors of 48 first. Well, let's start with the easy one. So we have 1 times 48 is 48. 2 definitely goes into 48. And remember, if you don't know, this is where you can either use multiplication to help guess and check or divide, right? If I think about 48 divided by 2, or what number times 2 is 48? Well, that's going to be 24. 3 also goes into 48 because 3 times 16 is 48. We still have some more, so 4 goes into 48 12 times because 4 times 12 is 48. And then last but not least, 6 times 8 is also 48. So those are my factors of 48, and now we have to write our factors of 56. So I'm going to draw my T-chart again, and then we'll list them. So easy one, 1 and 56 are factors. 2 times 28 would get you 56. 56 cannot be divided by 3 evenly, so we're going to skip to 4. And 4 times 14 is 56. And then last but not least, 7 times 8 would get us 56. So from here, we need to take a look at both set of factors and see what is my greatest common factor. So remember, greatest is our big key word here because we have multiple factors that are in common, right? Both of these have the number 1, both of these have the number 2, both of these have the number 4, but none of those are my greatest number. In this problem, our greatest common factor would be the number 8. Okay, so GCF for this problem is 8. Okay, so what does that tell me? Well, back to the problem, the original question said, what is the widest box that would work? Well, it's a word problem, so don't forget your units. If my GCF is 8, that means the widest box that would work could be 8 inches wide. So our final answer to our question is 8 inches wide. All right, problem number 2. Tours for the Colosseum leave every 8 minutes. Tours for the Vatican leave every 10 minutes. How often do the tours leave at the same time? So there's our keywords. At the same time tells us that we are doing LCM, right? If something is happening, an event is repeating, or two events are happening at the same time, we're going to be doing LCM or least common multiple. So least common multiple means I need to list my multiples for my two numbers in the problem. Our two numbers in this problem were 8 and 10. So I'm going to go ahead and start by listing my multiples of 8. I always say like a safe number for listing your multiples would be listing the first 5 multiples, just in case. And if you need to add more, you always can. So let's list the first 5 multiples of 8. So that would be 8, because 8 times 1 is 8, 8 times 2 is 16, 8 times 3 is 24, 8 times 4 is 32, and 8 times 5 is 40. Okay, and then our second number was 10, so let's list our first 5 multiples of 10, which should be fairly easy. 10, 20, 30, 40, and 50. So notice we did find our least common multiple, right? We're looking for the smallest number that they have in common, and in this case, it is the number 40. So our least common multiple would be 40. So what does this tell us? What does that 40 represent? Well, let's look back to the question, and it says, how often do the tours leave at the same time? So the tours leave at the same time every 40 minutes. So don't forget your units on this problem because it's a word problem. All right, problem 3. KISS FM is giving away free movie tickets for every 6th caller. They're also giving away Applebee's gift cards to every 10th caller. Which caller will be the first to receive both movie tickets and Applebee's gift cards? So if you think back to our keywords, remember that keyword both tells me I'll be doing LCM, right? It's an event happening at the same time, right? They're getting movie tickets and Applebee's gift cards. So we're going to be finding our least common multiple for the two numbers in our problem, which were the 6th day, so 6, and the 10th caller. Oh, I meant 6th caller and 10th caller, sorry. So same numbers. We're going to be doing multiples of 6 and multiples of 10. So remember, my safe bet is always to start by writing my first 5 multiples. If I need to add more, I can. So let's just start by writing our first 5 multiples of 6, which would be 6 times 1 is 6, 6 times 2 is 12, times 3 is 18, 6 times 4 is 24, 6 times 5 is 30. First 5 multiples of 10, just as easy. So 10, 20, 30, 40, 50. Yes, you could have stopped as soon as you see the number 30. You see these are our least common multiples, or least common multiple is 30 for this problem. So what does that tell us? Look back to our question. It says, which caller will be the first to receive both movie tickets and an Applebee's gift card? Well, caller 30 would be your answer. Done. All right, problem 4 says, the 6th grade teachers bought food for a reward party. They purchased 64 bags of, that should say chips, and 80 bottles of water. What is the largest number of students that can be invited to the party so that they each get the same amount of chips and water? All right, well, our key word here is largest, right? If we're looking for the greatest or largest number, that means we're looking for GCF, our greatest common factor. So our two numbers that we're going to use, 64 bags of chips, 80 bottles of water. So let's start with 64. We need to make our T-chart. 64 is at the top. And now we need to list our factors. So easy one, 1 times 64 is 64. 2 times 32 is going to be 64. 4 and 16. And 8 times 8. So again, if you don't know your factors off the top of your head, remember you can use your multiplication for guess and check, or do some division. 64 divided by 2 will give you 32. So second one, we have to find the GCF of 80. So I'm going to make a T-chart again and start listing my factors. So 1 times 80, 2 times 40. Well, 80 divided by 3 does not go in evenly, so I need to skip to 4. 80 divided by 4 is 20. 5 times 16 will give you 80. And 8 times 10. So those are all of our factors. Now our job is to say, what is the greatest common factor? So we got to go through the whole chart, because 1 and 1, they're the same, but that's not the greatest one, right? We need to look for our greatest common factor, and in this problem, it would be the number 16. So we can say greatest common factor is 16, but what does that mean? So let's look back to the question. It says, what is the largest number of students that can be invited to the party? So it would be 16 students. So make sure you have your units on the problem, please. All right, last one. Miss Townsend is making baggies of Skittles and M&Ms for all of her students. She has 66 Skittles and 36 M&Ms. If she makes identical baggies, how many Skittles will be in each? So this is not just GCF or LCM. We did learn a couple of problems just like this. So first things first, we have to either find LCM or GCF. So let's do that. If she's making identical baggies, that means she's splitting something into groups, right? She's splitting Skittles and splitting M&Ms into groups. So if she's splitting something up, that is going to be GCF, right? We need to find our greatest common factor. So the two numbers we're going to find or use are 66 and 36. So let's make our T-chart. 66 is our Skittles, and 36 would be M&Ms. So T-chart, and we need to list out our factors. So factors of 66, we can start with 1 times 66, 2 times 33, 3 times 22, and then all the way down to 6 times 11. So those are our factors for 66. And now our factors for 36, we should do 1 and 36, 2 and 18, 3 and 12, 4 times 9, and last but not least, 6 times 6. So those are all of our factors. So now our job is to find what is our greatest common factor, right? What's our common factor between 66 and 36? When we look at this, 6 is our greatest common factor, so I'm going to circle it. So you can put GCF is 6, but all that tells us is that we can make 6 identical baggies. But that's not what the question was asking, right? The question asked, how many Skittles will be in each bag? So once you found that our GCF is 6, we have to then look at our Skittles and see, okay, what number is right next to our GCF, which was 6? And when we look at it, we'll see the number 11. So what does 11 mean? 11 tells us that in each bag, right, there's 6 total baggies, there will be 11 Skittles in each. And that would be our final answer.